Welcome to this video on real-world graphs. By the end of this video, you should be able to model real-world scenarios using graphs. So the first thing we want to do is we want to take a look at our graph and we're going to describe it over here. So this is talking about a roller coaster during the ride, and we have time in seconds on the x-axis and we have the height in feet on the y-axis. So you want to kind of think about it. So this is where your ride begins. Okay, and then it goes up a big hill. So let's write that. So let's see how this matches. It says the roller coaster left the gate or wherever it started from, and it climbed up before a large drop. So here it's left the gate, it climbs up, and then it has a large drop. Now let's look. Here the roller coaster begins to go up again. And then it's going to drop again, but notice this drop is not near as far as that drop. It's a smaller drop. So we could say the roller coaster climbs up again. And maybe let's even say, if you notice, it's not as high as it was the first time. Before a smaller drop. And then what happens? We're going to climb one last time, not as high as the first, before one last big drop, and then the ride will end. Okay. Okay. So our goal here was to describe what was happening here in words. What we're going to actually do is you're going to be given some words and we're going to graph them. So if you can work it this way where you look at the graph and describe it, you can read the description and do the graph. So let's take a look at number 2. It says, in a single day, it snowed lightly during the morning, then heavily for the rest of the day. Graph time on the x-axis and the total snowfall amounts on the y-axis. So we're going to put time on the x. You're going to put total snowfall on the y. Okay, so it snowed lightly in the morning. So is that going to be a steep line or a not steep line, a flatter line? If it's snowing lightly, the total snow doesn't add up quickly. So we can do, maybe it snowed lightly, and then what happened is then heavily for the rest of the day. I don't know, what's heavily? That would show there's a lot of snowfall for the rest of the day. So really that's what we're doing. You're going to read these directions and see if you can make a graph that matches it. It's very important. The last sentence here tells you what your x and y axes are, that you label them. Let's try it again. They get a little more complicated. So Mia bought a painting. The value of the painting dropped. Okay, it dropped, so you got to think going down by 25% after 1 year, and then increased in value over the next 5 years, reaching a value that was twice what she had paid for it. Twice what she had paid for it. So that means we're going to want to go up two times as high as we started with. So we got to think about that when we're putting it on the graph. Graph time on the x-axis, and we'll put the painting value here on the y-axis. All right, so let's take a look. So Mia bought the painting and it dropped in price by 25%. So I was kind of envisioning this broken into fourths. By 25% in the first year, and after that it reached a value that was twice what she paid for it. So if this is what she paid for it twice is about this height. So I'm going to draw some over time that kind of takes me up to where I think about 5 years is. You could have been a little more stretched out. That would have been fine. But the idea is you had like a quarter of a drop and then a twice the amount growth over time. All right, one last one and we'll talk about some more in class. So a basketball was dropped out of a window on the second floor of a school onto the concrete below. Each time the ball hit the ground, it bounced and reached a height that was half the previous bounce. It continued doing this until it settled on the ground. Graph time on the x-axis and distance from the ground on the y-axis. Okay, so we've got time and distance from ground. I guess we could have called that height, but they called it distance from ground, so that's what we'll call it too, distance from ground. So imagine what happens. You're up here on the second story window and you drop the ball and it hits the ground and it bounces half as high, and it comes down and it bounces and it goes half as high, hits the ground, bounces, goes half as high. And so each time you're only going half as high until it settles on the ground. So it kind of peters out there at the end. All right, so we're going to talk about the rest of these in class. Hopefully that was helpful. See you in class.